Simulating a confidence interval for a sample mean. So if you've had a look at the PDF that goes with this video, number 576, you'll see we're going to sample from a binomial distribution, although we could sample from any distribution. But here we go. So we'll go into main and we'll get the keyboard up, head down to the catalog of functions and across to the random tools. Here we are. So the ones beginning with R. And let's just start off with a random binomial. Now, we are saying that we're packing lollies into packets of 20. The probability of getting a red was 0.25. So if we start off just by having a look at that, you can see here we've actually ended up with 7 reds in our first sample packet. Now that's all very well, but if we want to do it a little bit quicker than that, we can put in an extra parameter and maybe, here we could choose 3 samples, for example. So we've got 8 in the first sample, then 3 in the second and 7 in the third. Or because we know that we require the number of samples to be fairly large, let's go for 25 and take a sample of that. Now the next thing we want to do is work out the mean of our sample here. So going to the functions beginning with m, you can see here's the mean, and tapping onto that one, the mean of that last sample was 5.04. But we can put it all together by taking the mean of a sample of 25 and tap execute, and we can keep repeatedly get our samples that way. Now for a confidence interval, we need to, and we're going to have a look at a 90% one. What's the z-score for this fella? So we'll get rid of the keyboard and head off to interactive, distribution, inverse, normal, CDF. Now, to work out the z-score for a confidence interval, we choose the centers tail setting. The probability would be 0.9 for a 90 for a 90%. And we leave the mean and standard deviation as they are, and that tells us that the z-score that we're going to need for our confidence interval is 1.645. So now the next thing we're going to need to know is the standard error for the distribution, because we've got a normal distribution here. So we'll start off with a fraction, and upstairs we're going to want n multiplied by the probability of success, which is 0.25, multiplied by 1 minus the probability of success. So 1 minus 0.25. So that's the first bit. But because our sample size is 25, that needs to go downstairs. And last of all, we need to square root this value. So what I'm going to do is select it, shift power to tuck it under the square root. And then we could actually store this value as the standard error. So now if you use shift keys, it's shift subtract store, or under the keyboard, if we head back up, you can see it's here, the top right one, but we've already got one, and we'll use SE for our standard error there. Now we've already got a sample. Where was it? Up here. So let's use that as our sample proportion. So I'm going to close the bracket and store that little fella. Here we go. Shift power as our P for our P for probability. So I just need to tap execute. Oh, invalid name, it says. I don't know why it's not happy with P. Let's choose M instead and tap execute, and invalid name on that one. Oh, I need to close one more set of brackets. I think that's all that was going on here. So, and I'll tap the finger just so that it recalculates. So here we go. We've just got our sample mean of 4.92. Our standard error is here. So we're ready to set up our confidence interval. Here we go. So down here, it'll be the sample mean plus the z-score of 1.645 times the standard error, so times SE. Now I'm going to store that, so shift negative sign as my lower value for the, that would be for the lower value we'd need to subtract, wouldn't we? So we'll tap execute on that one. And we're basically going to repeat this, only we're going to add the 1.645 times the standard error, and then our backspace, and we'll call this the high end. So we've got our lower and upper limits of our confidence interval here. Now the last thing I want to do is work out whether the actual population mean, which was NP, remember that's 0.25, what are we doing here? Oh, we've got packets of 20, so NP would be 5. So we're expecting an average of 5. And obviously our interval does contain the mean. If we wanted to do this, and because we're going to do it in the spreadsheet in a minute, and I've got the ABC menu here, I'm going to use the judge command and just show you how it works. So we can judge whether we need to go back to here. Oops, where did that Z come from? Whether the lower is less than, so that would be on Math 3, is less than 5 is less than, we'll take the higher from here, right? How about that? And when I ask the judge command whether this is true, it says yes it is. Obviously if I just change this for the moment to something like 3 and hit execute, you can see because 3, the interval doesn't contain 3, then it's come up with false. So we can use this in a spreadsheet to sort of repeatedly simulate what we've just done here in main. So all good. Let's now, what do we want when we go into the spreadsheet? It's basically our method here for taking our samples. So here we go. I've taken a copy, edit copy of the key line here, which is taking our sample, and we're going to head off to spreadsheet. As usual, we start with an equals sign and then paste in our formula and hit the tick. So here's our first sample. The next thing we need to do is work out in cell B1 the lower end of our confidence interval. So we start with an equals sign, and then we want to say it's the number in cell A1, subtract 1.645 for the 90% confidence interval, multiplied by the standard error, which was 0.387 from memory. Yep, that was it. So there's our lower band for the confidence interval, and then we want our upper band, which is basically going to be the same formula. So here we go. It's equal to the value in cell A1, but this time it's add 1.645. Now you could set up a more complicated spreadsheet where you sort of have different cells containing these values, but for the moment we'll keep things simple. We'll just type them in and manually change them if we want to maybe do a 95% confidence interval. So there's our upper limit. And then in the last cell over here, we want to just judge whether these two values contain the known population parameter. So here we go. It would be an equals. From the keyboard, we can either type in judge from the ABC menu as we did in main, or we could head off to the catalog of functions. Oh, I just missed J somewhere around here. Here it is, J, and it's the only one in the whole of the ClassPad that begins with a J. So we'll input a judge. Whether, now we need to come up to here, the value B1 is our lower, and then we're going to need to go back up to Math 3 to get the less than 5, our expected value less than the value in C1. C1 and tap execute, and it says true. Now we've basically got we're sampling one confidence interval here. It would be nice if we could tidy up these columns. You can either manually drag and adjust the values, or I'm going to select the first 4 columns here. You notice I've got cell D as well, and go to edit, format, column width, and I've done this before. I know a width of 62 would work pretty nicely on this one. So you can see now, we can see all 4 columns. We've got the sample mean, the lower and upper end of our confidence interval, and then it's saying whether it's true or false. Now we want to just repeat this a few times, so I'm going to get rid of the keyboard, and if you've never done this before in a spreadsheet, here we go. we're going to tap onto A1 and simply drag across to D1 to select the whole row. And then it's simply a matter of tap onto the value in A1 and drag it down. Tap and drag all the way down. And let's do this 10 times. So each time you can see we're getting new values appear. And let's have a look. When we're finished, we've got 2 falses and 8 trues. Now, for a 90% confidence interval, you'd expect 9 out of 10 times the interval would contain the true value. So we're not quite meeting with expectations here, but we can always try file, recalculate, and see what happens. Well, this one's kind of perfect, but I guess if we do it again, we'll probably get some different results. Well, here again, we got 1 out of the 10. File, recalculate, and so on. This time we got 3 that actually didn't contain the known parameter. So that's the way to simulate a confidence interval. And obviously we used in cell A1 here, we were sampling from a binomial distribution, but you could just as easily be sampling from a uniform, a Poisson, a normal distribution. It's just a matter of using the relevant function.